In this particular section of our educational program, I would like to talk about disease management and some of the things that we deal with in this case. And in doing so, I just want to remind us that integrated pest management is a very important concept around the world, whether it's in the U.S. or Malawi or other countries. It's very important, and what we often think about in the IPM approach is to prevent the pest from being an issue to begin with. If we happen to have the pest in a particular field or setting, we want to avoid the damage from that, or avoid the pest, which results in avoiding damage. If we certainly can't prevent and we can't avoid completely, we want to monitor those pest populations, and based on that monitoring, we want to suppress those pests. And I know in some cases pesticides can be a controversial topic. We want to be very careful with how we use those. We want to protect the food we produce. We want to protect the people that are involved in the production of that. We just want to really make sure we're safe when we use those. But there are places in many circumstances where pesticides bring a lot of value to our production system, and the use of those can increase our profit by several fold above the cost of that particular pesticides. But we know that stewardship is an important part of using a pesticide in a production system. But we want to prevent, avoid, and monitor, and then finally at the suppression stage, in many cases that could be a pesticide. So it's what we want to avoid if we can do it, not only because of a safety standpoint, but just the mere cost of that input in our production system. But we know that when we need a pesticide in many circumstances, it more than pays for itself in those roles. Again, if we start thinking about pesticides, and this would apply to insecticides and also herbicides, but here I'm going to talk about fungicides in just a few minutes. We want to consider the cost-benefit analysis. So does it truly generate value in our production system? And for some pests, we really know what the numbers are on that, and we can make good recommendations. For some other pests, it's not entirely understood completely, and we know that we can have a lot of variation in our production systems and the response. But it's certainly important to consider the cost-benefit analysis. We always want to store pesticides in a safe place where people and livestock can't gain access, and this is especially true for children. As we know, as adults, we know if we've got something in a container and we know that it's not safe, we'll avoid that, but children just don't know that. We know that pesticides get stored in things that they shouldn't, in bottles that aren't properly labeled, and that's where we run into great risk with not only adults having issues or livestock, but especially children. So we want to be very careful. For the people that are making the applications, people need to wear protective equipment when handling, mixing, applying, and cleaning up equipment. All the way through that process of handling, we want to make sure we do that. The containers that we use, we should really discard those. We shouldn't. If we reuse those for the pesticide, that's one thing, but if we definitely don't want to reuse those and have those laying around, because there could be residues in those. We do want people to, when they have the options, to select different pesticides. Say, for example, insecticides. If you've got 2 or 3 different ones to choose from that are close to being equally effective on the pest in question, we would want to select the one that has the least potential to have an adverse effect on the environment or on the applicator. So we want to be as safe as we can with those, and there's a lot of good information on the risk of handling pesticide A versus pesticide B, and we want to handle and use the one that is the safest to handle whenever possible. Our sprayers, we want to calibrate those frequently. If it's a more advanced system with a tractor and a sprayer, we know that we can have wear on the nozzles that are used to deliver pesticides, so we want to calibrate frequently. If it's a knapsack sprayer, over time, even the orifice on a knapsack sprayer can become um, worn, and you might have higher delivery. So we just want to always check and make sure we're delivering the right amount. So one of the key things is in pest management is to ID the pest or the damage, and then we want to calibrate and make sure we're applying the correct amount at the correct time to get pest control. And we want to keep accurate information on our pesticides so that we can caution people from entering fields if we've used a pesticide recently. We also want to determine how effective that was. So if we keep good information on the pesticides we used, when we used them, we can assess their effectiveness and we can get a better sense of whether we should use those in the future. So shifting over to plant pathology, that was just an introduction on pesticides, and that's if we start using pesticides, we just have to be good stewards of the use of those. So we often deal with leaf spot in peanuts, and just to remind you that not all leaf spots are caused by pathogens, and the ones that we're in most cases worried about dealing with in groundnuts, that would be the ones that produce lesions and there's a pathogen that does it. But we can have leaf spots caused by any number of things that actually don't plate out. In other words, there's not an active pathogen. And part of that is where the lesions occur in the canopy. So if we think about our traditional leaf spot, early and late leaf spot, we're generally going to have those developing lower in the canopy. And here's an example here, both on the left and the right. As you look down in the lower portion of the canopy, you'll begin to see some of those lesions down low. And certainly the spores from leaf spot or the pathogen that causes leaf spot can be distributed by air and over some relatively long distances. But we also know that that pathogen has developed near the soil or in the soil surface from residues from the previous time, so that pathogen has been able to survive, and it's going to begin its infection lower in the canopy. That's where the original leaves are. They're the oldest leaves, so you'll tend to get the pathogen, the spores, moving up on those leaves, and again, they've been there a longer period of time for exposure. And over time, that pathogen will move the spores, and the infection and the lesions that you'll see will move up through the canopy. Again, that's usually a pretty good indicator of if that pathogen or the lesion you're seeing is, or the spots are caused by the actual pathogen, is where they begin. So this is early leaf spot. This is late leaf spot. This can be a huge issue as well. This is a more close-up of the canopy rather than showing the distribution throughout the canopy. Now, this is the life cycle of leaf spot, and I'm not going to go all the way through this. I think one of the most important things is to remember is that you'll get infection in those cells, and then over time you'll get the lesions that are produced. You'll have more of the spores that are produced, and those can be delivered in the air, and you can get reinfection or not reinfection, but a greater infection throughout the canopy as those populations and spores build up over time. One of the key things that we encourage people to remember is that, and it's shown in the middle of the life cycle here, is that we encourage rotation to break the cycles of many of our pathogens, and certainly the pathogens that cause leaf spot would be important to consider this too. But if we have bridge crops from one year to the next, let's say for example we grew groundnuts this year and then we had maize in that field the following year, if we have volunteer groundnuts in that maize, and it could be that the population of groundnuts is, we're not trying to harvest those, but they come up and they're in that field, they're going to continue that cycle, that building of the cycle. So we want to, one of our management strategies is to realize that, to try to break the cycle so that we don't have a situation where we almost have continuous peanuts or groundnuts. We would have certainly lower numbers of plants from those volunteers, but they can bridge that for the next time we go into that field. So Rotation is only as effective as the crop we rotate to and how we handle the volunteers that come up the following season after we had groundnuts in that field. So that's the general life cycle. And once the life cycle of this pathogen gets going, especially if you have the right temperature and humidity, which are the two environmental factors that drive the pathogen development, and then certainly the lesions that are produced in the epidemics we have, we can just have huge numbers of spores that are produced, and that's why things go downhill very quickly. And just to demonstrate that, this is a picture from the U.S., but I think it would be very common to see almost anywhere where you have warm, moist environments and the pathogen present. So on day one, you can see that we have some lesions down at the bottom of that particular plant. They're at the bottom, but they probably go up about midway in the canopy. And then about a week later, you'll see that many of those leaves that were infected down near the bottom of the plant, those have been defoliated. So that is just a rapid decrease in the foliage. And then about a week later, you'll see that we have very few leaves left in that canopy. And what we know is the health of that plant goes downhill very fast with those lesions. And as we have those leaves that fall off due to the lesions and the damage caused by the disease, we will also have the pods that certainly will not continue to develop in many cases, but they'll also shed from the plant. So we want to avoid that, and a couple of ways we can do that. One is to get resistant varieties if we have those available. We're limited in terms of that right now in Malawi, but can you target a fungicide? Now there's other cultural practices that you could do to minimize the incident of that pathogen, and we'll talk about that a bit as we go. And this is an image from our peanut maturity chart, which we'll talk about peanut maturity or groundnut maturity a little bit later on. But we have this on here just to remind people that there's a exponential growth phase where you have some lesions produced on a plant. It's not terribly bad early on, but the way pathogens develop, you hit this exponential phase where once it gets going, it really gets out of control fast, and there's no way to really handle that well once the epidemic builds. So you have the lesions produced. That's the black line here, and then what's going to happen not long after that is you're going to have defoliation, and certainly there's a lot of concerns about COVID-19 around the world right now, and it's a big issue for almost everyone, and a cautionary tale for everyone. And I'm around groundnuts all the time, at least during the summer and fall, and now my perspective on leaf spot is tangled in with human health as well, knowing how quickly things can go downhill, or lesions can develop, and then defoliation, and then ultimately plant death or loss of pods and so forth. So there's pathogens once those epidemics build, it's very hard there's no way to control them once they build. And I know fungicides are not used on a large scale in Malawi, but one thing we know is that once we get, for example, here, 20% of the leaves have visual lesions, what we know is probably 60 or 70% of the entire canopy is already infected with the particular pathogen, and we don't have any fungicides that have appreciable curative action. Most of our fungicides, essentially all of our fungicides we'd use in peanuts, are protective. Occasionally one might have a little bit of curative activity, but most of them are protecting. So once you get 20% of that canopy with lesions, you've got 60 or 70% infection already. It's just the lesions haven't shown up yet. So these epidemics can get out of hand. Many of you that are around groundnuts have experienced that. And then there's always that battle of, well, how much defoliation am I going to have relative to when the crop will mature? And we'll spend a little more time on that under the maturity section. Another important pathogen and a disease we have to deal with is rust. And in this particular group of images, I'm showing some rust. Those would be the smaller bodies there, fruiting bodies or pustules there. And then you've got the larger, darker lesions. Those are caused by late leaf spot. So managing leaf spot and rust, two very important diseases to manage. One thing is having a good rotation sequence with a non-host crop. So in other words, understanding what crops would be a host or would be a medium for those pathogens to develop and continue their life cycle. Maize, for example, and tobacco are certainly good rotation crops for groundnuts that can help us reduce leaf spot and rust. But keep in mind that if we don't do a good job in our rotations keeping groundnut plants out of tobacco or out of maize, that's a bridge to the next time we have groundnuts. So you can continue that life cycle, and you'll just, the next time you have groundnuts, you'll be starting with a higher level of inoculum in the soil and the plant material there, and then you're just going to have bigger problems, even though you maybe had what you thought was a good rotation crop. Again, removing volunteer plants is important. We do feel like if you sow groundnuts early in the season, you're better able to handle things. We would say if you have resistant varieties, that would be a good avenue to go. The question is, what do we have in our variety selection here? There's a lot of work going into trying to develop resistance in our systems. Remove or bury residues of infected groundnuts. That can be an important practice to carry out. There's always the debate about long-term sustainability of soil systems when we begin to either remove residues, especially, or if we do a lot of tillage, to bury residues. We can decrease that organic matter over time if we just always take out of the field. But from a disease management standpoint, it can be a plus. And then if we have access to fungicides, can apply those in a timely manner, we can make great strides in protecting that plant from the disease. Again, rotation sequence is important not only for the nutrient cycling, for example, for nitrogen fixation from, say, groundnuts to maize, but also for breaking those cycles. But keeping in mind that we've got to keep those volunteer groundnuts out of the rotation crops if we're going to get the full benefit. From a fungicide standpoint, and this would be things we think about for both rust and leaf spot, I've abbreviated these, but the strobilurin chemistry or the triazole chemistry, and there's a number of trade names in here. I'm just using the broader description here of the chemistry behind it. Applying one of those at 30 days after planting, that's a good time to start those applications. And then at 45 days, about 2 weeks later, you would come back in with the next one. So for example, I would use a strobin first and then a triazole, or I would use a triazole first and then come back with a strobin. We want to rotate our chemistry to minimize the likelihood of selecting for resistance. And then at 60 days after planting, we might come in with a chlorothalonil treatment. Again, there's several different trade names for that at 60. Now, I'll be honest with you, this is the program that I would think would work the best, but in essence, if you can get one application really helps, 2 is better, and 3, if you look at our growing conditions in Malawi, and especially if we have an abundance of rain, it would take 3. In many cases, if you have access to credit and could purchase these materials under many of the conditions you would have in Malawi, they would deliver a positive economic return on the investment. But again, even one application could make a big difference. 2 and then 3 would be the ideal at this point in time from what we know about protecting the crop. But again, timeliness is important. If you remember that picture I showed earlier on where we had, once you got to 20% lesions on that plant, there's really very little value in making an application after that point because you already have infection. So what we want people to do is use the fungicides earlier in the season so that you prevent the infection and you protect that foliage. And if you continue to do that for a period of time, you really get ahead of that epidemic curve, and that makes a big difference in your yield potential. So keep that in mind as you get access to the fungicides and decide how to use those in these systems. So groundnut rosette virus, that's an important one for us as well, and all across Africa, but certainly an issue in southern Africa and Malawi. Again, this is a virus that's vectored by the groundnut aphid. A little more not chemistry, but biology back here. There's the virus, and there's RNA, and those are packaged in a manner that that can be when the aphid feeds, you get plant infection, and then as the aphid moves from one plant to another plant, you can increase the infection there. One of the challenges that we have is managing that, in part because even if we had an effective aphid program, an insecticide program for that, usually that's from a systemic insecticide, and that systemic insecticide, the aphid has to feed on the plant to receive the systemic insecticide, and by the time the aphid feeds, it's already transmitted the virus into that plant. Now, those applications can minimize further spread of the virus in that plant, in the population of groundnut plants in a field, because that aphid doesn't continue to go to other plants. But a lot of times, if there's a high enough aphid count in the field, that might be a relatively minor contributor to rosette virus resistance, or not resistance, but the prevalence of that particular issue of groundnuts. So some of the ways that we would manage rosette, one would be to sow early, and we know that the earlier we sow, the healthier our plants will be, but also we will we'll avoid some of the issues with the aphid, which is the vector. We want to establish optimum to high plant populations. So if you're in an area where you tend to have a lot of rosette, one of the tools you could do is increase that plant population. There's some interesting thing that goes on with the insect here, whether it's their ability to visualize the canopy and what's more attractive or less attractive based on reflectance of soil and plants, but also just the fact that if you've got more plants, you've got more plants to compensate for the ones that do get the virus. Removing volunteer plants can be a positive. Again, we talked about that with the rotations. We do have some varieties that are resistant or have some tolerance, certainly, to rosette. The question is in all the cases when we talk about variety resistance, are those varieties that have the resistance, do they match what the market needs? And sometimes we run into challenges where what's most marketable and what the industry needs turns out to be the more susceptible ones. But these are two of the options that one can think of. One thing that we do know in general, the rotation sequence, the fungicides we use, insecticides we use, they don't have an appreciable level of control of rosette. It's certainly an insect vectored virus, and it gets complicated in that sense. There's a lot of vegetation that can also harbor or can be fed on by aphids, but also can maintain virus levels, and that's where we get into big challenges. But this is where the resistance in our varieties is over time is probably going to have our biggest impact. But we do know that if we establish higher plant populations than what we're establishing in many fields now, we can greatly reduce rosette and help us manage that more effectively with our higher plant populations and earlier sowing, for example, as well.